state space model. So I'll just refresh this one so that you recall it. Okay, so we considered a spring mass damper system. So this is a spring mass and a damper system where you apply a external force. Okay, so the equation for this will be mx double dot. So this is k and this is c. Okay, mx double dot plus cx dot plus kx is equal to u of t. So this is from the Newton's second law. So this can be written like mx double dot is equal to minus kx minus cx dot and then plus u of t. So here what we do is we write x of t equal to x1 and x dot of t is equal to x1 dot. Because x of t is equal to x1, then x dot of t will be equal to x1 dot, and this will write it as x2. Okay, and this u of t will take it as u1. Okay, so if we have to write this, so what will be x double dot of t? It will be x2 dot. Okay, x double dot of t will be equal to x2 dot. So this we have discussed before. So I'll just recap these things. So we wanted it in the form of x dot is equal to ax plus bu and y is equal to cx plus du. This is the form of the state space model. Okay, so this, it has to be written in this form. So how do you write that is you have this thing, you have this equation. Okay, so substitute the values mx2 double dot, instead of mx double dot it is mx2 dot. Okay, so u1 minus kx1 minus cx2. Okay, and this will be x2 will be x2 dot will be equal to, if you take m down, it will be u1 by m minus kx1 by m minus cx2 by m. So this x1, what is x1 dot equal to? X1 dot is equal to x2.
Yes, sir.
Okay, so x1 dot will be equal to, if you write for u1, it is 0 times u1 and 0 times x1 and then 1 time x2. Okay, it is nothing but writing it as x1 dot is equal to x2. So this, if you want to write it in the form of ax plus bu, you can write it like x dot will be x1 dot and x2 dot. Okay, so this is x dot, okay, is equal to this will be take the x1 and x2 terms here. Okay, so this will be this is x1 dot, so this is 0 here, 0 x1 and 1 time x2, and this is minus k by m and this is minus c by m. Okay, and this is multiplied by x1 and x2, and then plus what is left, this u term. Okay, so this is 0 and this is 1 by m. So this is 0 and this is 1 by m multiplied by u1. Okay, so this is a, this matrix is a x plus b u. Okay, x dot is equal to, so this is the matrix for x dot, this is a matrix, this is x plus this is b matrix and u. Okay, okay, so next is this equation is written, x dot is equal to ax plus bu is written. We have to write for y is equal to cx plus du. What is y is equal to? Y is the output. Okay, y will be equal to x1, the displacement. So what will it be equal to? So if you have to write it in the form of cx, it will be 1 and 0 because there is no x2 term. So this is x1 and x2. Okay, how y is equal to x1? X of t is equal to x1. X of t is the displacement, right? So it is taken as x1 here. So y is equal to 1, 0, x1, x2. And then plus what is d? D is 0 here multiplied by u1. Okay, so this is 0. So y is equal to x1. This whole thing is just saying y is equal to x1. That's all. This whole thing is saying y is equal to x1. So this is how you write it in this form. X dot is equal to x plus bu, y is equal to cx plus du. Now what is the relation between these two? It is the relation between transfer function and state space model. Transfer function and state space model. What is the relation? It is, I'll directly write this. Y of s, I derived this in one of the class. Just look into it. Y of s by u of s is equal to c into si minus a inverse si minus a inverse b plus d. Okay, so this is the relation between the transfer function and the state space model. This is a state space model, this is the transfer function. Okay, now we also looked at one of the main points, that is suppose if this is the model that you have taken, so what will be the transfer function of this? Transfer function will be output by input. What is the output? Output is the
displacement, sir.
Displacement. Okay, so it will be it will be x of s divided by u of s. U of s is the force input. Okay, so this will be equal to 1 divided by m s square
plus ks plus k.
1 divided by ms square plus cs plus k. So this is the transfer function. Okay, now how do we get the poles of this? Poles we get roots of the
denominator.
Roots of the denominator. Okay, so if put some values, put some okay, put some values here. M say is equal to 3, c is equal to 2, some random values I'm taking, k is equal to 1. Then transfer function will be 1 divided by 3s square plus 2s plus 1. Okay, so what will be the roots of this? For that just go find it out. 3s square plus 2s plus 1. I'll just I'm not share the screen. Okay. You're able to see that quadratic equation solver? Okay. Able to see it, right?
Yes, sir.
Okay. 3s square plus 2s plus 1. The roots are minus 0.33 plus 0.47i and minus 0.33 minus 0.47i. Okay. So this is the roots of this quadratic equation. So the poles will be that only. Okay. The poles will be that. Now, if you look at what is A matrix, this is A matrix. Okay. So substitute the values. A will be equal to what? 0, 1. What is K? K is 1, right? Minus 1 by 3. Minus 1 by 3 and minus 2 by 3. Okay. 0. We just took it as m is equal to 3, c is equal to 2, k is equal to 1. No. So I am just substituting the values. That's all. Okay. So this will be A matrix. 0, 1, minus 1 by 3, minus 2 by 3. Now